However, let's take a look at the standard form of the quadratic equation. It is ax squared plus bx plus c equals 0. In our graphing activity a couple of days ago, we took a look at what does it mean for a quadratic relation to equal 0. Well, if you remember, this 0 represents the y value of that quadratic relation. Well, when does y equal 0? When the x values are right on the x-axis, which means we're solving for the x-intercepts of a quadratic function. So, when you are asked to solve a quadratic equation by factoring, first you will have to factor the given expression by applying what we have learned in previous units. This means that I have to convert now a quadratic relation from standard form, or from something that kind of looks like standard form, to factored form. And if you remember, the factored form of a function was ax minus r times x minus s. Well, depending on how the quadratic relation presents itself, we will have different methods to solve these quadratic equations. Well, let's look at the first case. We call them simple polynomials or simple factoring, and this case presents itself when the coefficient of ax squared, or the a value, is 1. In this case, we're going to try and factor it into two different brackets by looking at b and c. And how do we look at b and c? We're going to say what two numbers multiplied together give me 30 and added give us 11. So I know I have x in each bracket, and I know that that c value comes from multiplying the last term in the first bracket with the last term in that second bracket. Well, let's think of factors of 30. We have 1 and 30, but when we add it, it doesn't give us 11. 2 and 15 would give us 30, however, they don't add up to 11. What about 5 and 6? Well, let's see. Positive 5 plus 6. Well, 5 times 6 gives us 30, so we check the b. And now, x times 6 is 6x plus 5x. We have 11x, which equates the middle term. Now, how do we solve this equation from this form? I want you to imagine setting each bracket in the form of a linear relation. So I want you to imagine setting each of these brackets as an individual linear relation. Where is the entire equation 0? When each one of these brackets will be potentially 0. So let's set up our first linear equation. X plus 5 equal 0. When does x plus 5 equal 0? When x equals negative 5. Now let's look at the second one. When does x plus 6 equal 0? Well, when x equals negative 6. So the two possible roots or solutions of this quadratic equation are negative 5 and negative 6. Let's look at example B. Now, as you can see, example B doesn't present itself in the standard form of a quadratic relation. It's different. Whenever we have something in between, it's not a pure vertex form, not a pure factored form, not a pure standard form, you want to bring it to the form that you are comfortable with working. And since we are asked to solve these equations by factoring, we have to bring this expression to standard form. What does standard form mean? Well, let's look again. Standard form meant that I had all the terms on the left side equal to 0. So, in my specific case, I have to subtract 3x and subtract 28, or move them to the other side, to get the right side to become 0. So my new expression will be x squared minus 3x minus 28 equal 0. And this expression is factorable as well. So let's think about what two numbers multiply to negative 28 and add up to negative 3. So I know I'm going to have x in one bracket, x in the other bracket. Well, the two numbers are negative 7 and 4. Let's verify. 4x minus 7x gives us negative 3x. Negative 7 times 4 gives us negative 28. And remember, if you're going to set each bracket as a linear equation, you will be able to find the two possible roots. So if x minus 7 equals 0, then x equals 7. And if x plus 4 equals 0, x equals negative 4. Let's look at the second case of possible quadratic relations. When a is not 1, we call this complex factoring, if you remember, or complex trinomial form. So we have 3x squared minus x minus 2 equal 0. And we're going to factor by using guess and check and see what the two possible brackets look like. We can factor this one by guess and check. So I know that 3x squared comes from multiplying 3x and x, going through factors of 3. Where does negative 2 come from? From either multiplying negative 1 with negative 2 or positive 1 with negative 1 with positive 2 or positive 1 with negative 2. Now I'm looking at the middle term and I know it's a negative term. So somehow I'm going to end up with negative numbers. So I will have something like negative 1 and positive 2 over here. Well, let's verify. Negative 3x plus 2x gives us negative x. 2 times negative 1 gives us 0. By now, I'm hoping that you got the hang of setting each bracket as a linear equation and solving for the variable. So we're going to set 3x plus 2 equal 0, which means that 3x equals negative 2 or x equals negative 2 over 3. For the second bracket, we have x minus 1 equal 0 or x equals 1. Let's look at that second example. Again, we have a complex factoring question and we're going to solve it or factor it first by using guess and check. Let's think of factors of 5x squared. What does 5 come from? From multiplying 5 and 1, having a prime number such as 5. So 5x and x. And now let's think about 6. 6 has multiple factors, 6 and 1, 2 and 3. However, we do notice that the middle term has a negative sign in front of it, which means that probably I should look at negative factors of 6. What negative factors of 6 can we find? Well, we can say negative 3 and negative 2. And when we're doing the verification, we have 5 times negative 2 is negative 10. Negative plus negative 3, it gives us negative 13x. We're going to set up the first bracket as a linear equation. So 5x minus 3 equals 0. 5x equals 3. Or x equals 3 over 5. For that second bracket, if we have x minus 2 equal 0, x will equal 2. And 3 over 5 and 2 are the two possible roots of this quadratic equation. Let's look on the second page at further cases. In this third case, we notice that the c value of the quadratic equation is 0. Well, this one is one of the easiest cases because we are left with only x terms. And no matter what coefficients that x have, either negative 4 or 7, 3 and negative 8, as long as I can group all the x terms on one side of that quadratic equation, I can factor out x. So in my case, I can factor x out and be left with negative 4, x plus 7 equal 0. Now you can go and set each bracket to a linear relation And please imagine this x as being its own independent bracket. Let's see what we get. So x would equal 0, or the other linear equation that we can create is negative 4x plus 7 equal 0. So 4x equals 7, or x equals 7 over 4. I will let you take care of case 3b on your own. Remember to factor x out of both terms. Let's look at case 4, when b equals 0. We do not have a middle term. Well, in this case, it's one of actually the simplest cases of solving quadratic equations because we have only one x term. And what we want to do is we want to isolate the x squared term from all the other terms in the equation. So in this case we'll have 4x squared, and we're gonna add 100 to both sides to cancel the negative 100 on the left side. So 4x squared equals 100. We can divide both sides by 4, and x squared equals 25. And in order to isolate x squared, we have to square root both sides, which means that x will be positive or negative 5. Please remember that whenever you're square rooting a positive integer, a perfect square, a positive integer doesn't have to be a perfect square. I apologize for that. A positive integer, the two answers could be either positive or negative. My hint to you for the one under case 4b is first find a greatest common factor and then apply a method. So try and find a greatest common factor, and then you will be virtually in the same position as in example A, and you're going to solve for x. Case 5, with fractions. In this case we are asked to solve for x. Remember, whenever we have fractions, we want actually to get rid of them. And the way you get rid of fractions in an equation is by multiplying the entire equation with the lowest common denominator. Why are we doing that? Well, let's look at what the lowest common denominator is. It's 10. So I'm going to multiply the entire equation with 10, which can be written as a fraction over 1. When I'm multiplying every single term with 10 over 1, I'm virtually reducing, cross-reducing, or cross-simplifying the denominators. Well, if I'm cross-simplifying 5 with 10, what I have left in the numerator is a 2. So I'm going to be left with 2x squared minus 15x, since I'm left only with a 5, equals 50. Now, looking at this equation, we're in that in-between case where it is almost standard form, but not quite. We do have to rearrange it. So we have 2x squared minus 15x minus 50 equal 0. And now you're in a complex trinomial, which you can factor, and you can move on from here. On page 3, I have a few more examples that we were supposed to complete in class. I do want to take up the last bit of the lesson plan, which was, if a question gives you the roots of a quadratic equation, how are you going to find the quadratic equation, the standard form or slope form, sorry, not slope form, or factored form or vertex form? Well, remember where the roots are coming from. They're coming from a x minus r, x minus s. Okay? Well, and in order to find r and s, we had to set each bracket to 0 and find the x value that equated that. So in this case, x would equal r, And notice that the r here has the opposite sign of what's in the bracket, and x would equal s. So what would be the two possible equations here? If x equals 6, the first possible equation is x minus 6 equal 0 for the first bracket. And if x equals negative 4, the first possible equation is x plus 4 equal 0. So the possible equation is x minus 6 times x plus 4 equal 0. And now you can multiply the two binomials and find what the standard form of the equation is. Let's try this one. Would be x plus 2 x minus 2 over 3 equal 0. Remember